Hi, I've been working on something and I'd like to show you what it does. It's an approach for composing music, or at least for now, phrases within a musical piece. Lots of generative musical composition algorithms might start with nothing and add notes until you end up with a chord or a theme or a progression of music. This takes the approach that's completely the opposite. Start with all the notes, start with everything, and then remove them through a series of special operations until what's left is a piece of music. So imagine a grid representing music, notes up here, and time along here. So we've got every note in every beat of the song. That's our initial state, and that's the same for every song. What we then do is randomly place a series of emitters. They're going to shoot little laser beams through this grid, and when a laser beam intersects with a note, it's going to change the note. It might remove it, it might alter its pitch, it might alter its space and time. So these vectors shoot through the grid. Different ones have different impacts. And over successive firings of those vector emitters, you're left with not a grid of everything, but just a piece of music. The different types of vectors can be things like a destructor, removing notes, shifting the pitch, moving them, reflecting them, or bringing other notes closer. But not every beam, not every vector is as powerful as the others, and each vector emitter has a power budget that is how far it can shoot through that grid of notes before it's exhausted. When two vectors intersect, things happen. It can change the effects they have, and it can change the direction they're going in. Now, those vector emitters, once you know what type of vector emitter it is and its power budget and its placement, are completely deterministic. So whilst we initialize with a full grid of every note and then randomly place the vector emitters, once you know that, you can recreate any piece of music because the starting state is known and the rules for how to change the grid of notes are the same, and so you end up with the same result. Now that means we can share a piece of music by simply sharing a single string that's a kind of encoding of where those vector emitters are and their direction and their type and power. Which means you can share a piece of music just by sharing that string and putting it through the same algorithm with the same starting grid of every note will result in the same output. So that's kind of interesting. We don't just fire the emitters once, they get fired a certain number of times to kind of change the music a little more. Now, that's kind of cool. But what we can then do is apply a learning algorithm. So we can take a corpus of existing music. We've got MIDI notes, and this is generating notes, not audio. It's generating notes happening at a particular time. We can take a series of MIDI files that represent other bits of music, and we can generate a statistical fingerprint of those that describes how the different notes in that music commonly occur. What's the average note? How many times do they have long notes, short notes, space between different notes? With that fingerprint, we can then compare two different bits of music. We can compare the music that we've got in the corpus, and we can compare a piece of music generated by Flex. The learning algorithm can then iterate the different types of vector emitter and different locations until it ends up with a a configuration that more closely matches the music of the original corpus. In the fingerprint, we have things that look at the pitch, the rhythm, harmony, and dynamics. I think this is an area where a bit more factors would be useful in terms of generating that similarity score. And not every piece is necessarily weighted equally in terms of the similarity. So, to evolve the perfect song, we initialize the population. We can do this in a big loop and generate lots of potential songs using a set of vector emitters, generate the batch of those different songs, extract the fingerprints from everything we've generated, score it versus the original corpus, rank and select the best ones, and then mutate and slightly alter those vector emitters from the best ones and repeat. And over time, the songs, the music that we generate should trend towards being more similar to the original kind of music in the corpus. This is all a Python script, so it runs in the terminal, but it can generate a thing that explains how that similarity score is being calculated and what are the biggest factors and common factors between the generated music and the original corpus. Here's an example of it running. So you can see it generates batches of different songs in parallel and then compares them to the original corpus. Over time, it trends towards being more similar to the original, and you can see that sort of happening there. It's a bit wobbly. Again, maybe it needs a bit more improvement and some more fine-grained control over the aspects in the fingerprint. Well, shall we have a listen? So this is a generation 1 song. So after the first generation of choosing emitters and listening and comparing. So after generation 1, we have something. Is it music? I'm not sure, but it's interesting, isn't it? Let's look at generation 3. So it's had more iterations and it's chosen a vector emitter configuration that has more closely matched the original corpus. So, yeah, that's after generation 3. After generation 5, so you can see there, it's evolved towards a piece with fewer gaps of silence, more kind of rhythmic changing and notes flowing one after the other. It's still very much a work in progress. Still changing how the fingerprinting works and looking at how we weight those fingerprint aspects. But it's generating something. Again, is it music? I don't really know, but it's interesting. Well, at least I think it is. So let me know what you think. Follow along on my YouTube channel, and I'll be sure to use some of this in some of the songs that I work on. Thanks.